Okay, modeling data with sinusoidal functions, and hopefully less coughing in this video. The daily average temperature for Calgary by month is shown in the chart below. The data has been collected for more than 30 years, and I'll show you the source for this. So this is where I got the data from. It's Calgary, Alberta, Canada, climate data, and what we're doing is taking the daily average temperature. So basically, if you take the average temperature for the day in Calgary every day in January, and then average those together, you'll get this daily average temperature. So take the average temperature for January 1st, 2nd, 3rd, all the way to the 31st, average those together, and the daily average temperature in Calgary in January is minus 8.9 degrees Celsius. February, March, here we are in April, where it's supposed to be 4.6. We're not quite there yet. Anyway, so that's the data that we're going to use, and we're going to put it into our calculator. We're going to run a regression. So these are the X values, which are the month number, right? So January is month 1, February is month 2, etc. And the Y values, which are in L2, are the daily average temperature. So we're going to put this into our calculator, and we're going to show a scatter plot of the data. So I'll start it out, and then I'll just finish it. So second plus, and I'm going to use number 4, clear all lists, just in case you had stuff. You could just clear your calculator and start over, or clear all lists. So we go to stat, and number 1 is edit. That's what we want, edit. And in L1, we're going to put 1 through 12. 1, 2, 3, 4. And so on. 7, 8, 9, 10, 11, 12. Arrow over to L2, and you should have printed the sheet, so you've got it in front of you. So negative 8.9, and then I'm just going to pause, and I'll go and enter the rest of the values. Okay, so I've entered all the data. Now double check. So make sure, because, if you're doing this for real, in real life, you're going to want to make sure you've got the right numbers. And if you're doing it on a test or something, again, you're going to want to make sure you've got the right numbers. So I've got the 12 with negative. I can see I've got 12, 11, 10, 9, 8, 7, 6, 5, 4, 3. So as I go up, and I'm just going to verify these, negative 3.1, negative 5.4. And what I do is I look down here, positive 5.4, 10.8, 15.6. 16.2, so I'm just going to drag that over a bit so we can see the rest. Okay, 16.2 is good, 13.8, 9.8, 4.6, negative 1.9. All right, so this is all good. Now we want to see a scatter plot, okay? In other words, we just want to look and see what shape this data is in. Is it a straight line? Is it a quadratic, etc.? So let's set the window. So we'll go from 0 to 12. Not that way we won't. So we'll go from 0 to, actually no, I'm going to go to 13. We'll go 1 month past. X scale of 1 is fine. And we've got values going as low as negative 8.9. So negative 10 looks good, and up to, and we'll go as high as 20. 16.2 is the number, but let's take that up to 20. And we're going over 30, from 20 to negative 10. Negative 10 to 20 is 30, so we'll go by 5s. Now, to see a scatter plot, we'll go to second y equals, and we need to turn this plot on. And on. And then I can hit graph. And what we see looks like a sinusoidal graph. And it sort of makes sense, right? I mean, we start off in January, it's the coldest month, with the coldest, lowest temperatures, rising up to July, August, when we get our warmest temperatures, and then starting to drop off again. Okay, so let us then Part B, use your calculator to find the sinusoidal regression equation. So I'm just going to quit out of that. We'll clear this. So we go Stat, Calc, Stat, over to Calc, not the Calc here. And sinusoidal regression's towards the bottom. Oops, and there it is there. So sin reg is what we want. And hit enter. Now with the older calculator, you're just going to see sin reg, and then all you need to do is follow it up with a y1. And on this, just work your way down to store regression equation. So if you're looking at sin reg, you're just going to put a y1 in. Here's how we get the y1. We go to vars, over to yvars, hit enter on function, hit enter on y1. So you're either looking at sin reg y1 or a screen that looks like this, and press enter, and you'll either get the regression, or on this you go to calculate, and then you'll get the regression. And it says round values to the nearest hundredth if necessary. Okay, so when I write this out, I don't copy the screen. I write out an actual equation. Y is equal to 12.72, 12.72, and it shows me the format, right? Sine, bracket, B, so 0.51x minus 1.98, so bx plus c, right, but the c is negative, bracket, plus 3.65. And we're going to put our calculator away for a bit, and we are going to analyze this function, right? So just as we did in the last lesson, we can look at this, we can look at our A, B, C, and D values, and we can figure stuff out, like what is the maximum temperature? Well, max, this is not on your formula sheet, right? You just need to know this is how it works, is D plus A. It's the midline, so 3.65 plus 12.72. So the max temp, okay, and this one I'll just work out on my home calculator, 3.65 plus 12.72. So the maximum, remember this is daily average, it's not the maximum temperature in Calgary. It's if you take the average, and we know that in the summer, yeah, it could get to 30 degrees, but it also cools down at night, so daily average. The minimum is D minus A, right? Remember, this is the middle. This is the variation from the middle. So that's 3.65 minus 12.72. So on my calculator, I'm just going to hit second function, enter, pull that calculation back down, hit a minus sign. We get negative 9.07. Round to the nearest 100. Now these have units. It's degrees Celsius. So the minimum daily average temperature. Now you know that does not agree with the numbers we have in the chart, okay? And nor does the 16.37 agree. But we're creating a model, okay? And models have limitations. Determine the period of the function, okay? So this one you do get on your formula sheet. The period is 2 pi over b. So the period is 2 pi divided by 0.51. Okay, again, just going to my calculator, 2 pi. And you can pause the video at this point and plug in the numbers yourself and check it out. And we get 12.31. And the period is in months. Okay, so don't forget units. If you're writing out answers, these have units, right? X-axis units are months. Y-axis units are in degrees Celsius. They are a temperature. Determine the start point and explain what this means in the context of the question. So if we want you to work out a start point, because this isn't given to you on the formula sheet, so we would give you the formula for start point. So for us, it's going to be negative 1.98 over 0.51, comma, and D is 3.65. Okay, so I'm going to use my calculator, and I'm just going to put 1.98. I know it's positive. Determined by 5.1 is 3.88. So 3.88, 3.65. So this is 3.88 months. This is 3.65 degrees. So in the context of this question, remember a start point. We haven't plotted the graph yet. We'll do that in a little bit. So let's see what we know about this. We go to a maximum of, so let's call that 16. Let's call that -10. Our average is 3.65. Our start point, so let's go 4 months, 8 months. Actually, you know what? Let's go by threes instead. So, hang on. Okay, let's go 3 months, 6 months, 9 months, and 12 months. So at 3.88 months, we're going to reach the middle temperature. And if we think about what is 3.88, so 3 months takes us into March, and 0.88 of a month. So let's go here. We're done with that. Clear that. So 0.88, and March has 31 days. It's going to take us to about the 27th of March. March 27th. Now remember, these are rounded values, so this could be a little bit different, but that's pretty close to the first day of spring. And if you think about it, that's how this works. We reach our average temperature. So our year-round average daily temperature in Calgary is just 3.65 degrees Celsius. We reach that average temperature around spring. Okay, our period is 12 months. Okay, so 12, we divide that by 4. So about every 3 months, stuff happens, right? So in 3 months, we'll reach, well, 3 months ago, we would have reached the minimum. So that'll be about there. And 3 months from now, so 6 and a bit, we'll reach the maximum. And then 3 months later, 9. Think about that. 9 months, September. Then we're at fall here. So this is spring. This is fall. This is summer. And then 3 months later, a little bit more, we'll reach the minimum again, and we're back to winter. So winter to spring to summer to fall, back to winter, and the cycle repeats. Right? So this is sinusoidal. We like the hours of daylight, right? Only this is daily average temperatures using data we collected off of the internet and ran a regression on, which gave us this equation, and we're analyzing a sinusoidal equation, just as we did, or sinusoidal function, just as we did the other day, right? We've got the middle. We've got the variance from the middle. That gives us a maximum temperature. That gives us a minimum. The B value gives us a period. And the start point in the context of this question is that we reach the median temperature of 3.65 degrees off the tablet, degrees Celsius in late March. Draw the graph of the function based on the above information. Okay, we did that. There it is. Oh, and I gave lots of room for it down there, eh? Oh well, it's there. show the graph of the function on your calculator and compare it to the one you drew. Okay. So let's go to the calculator. And I'm going to move that over so we can see the function, which I should have drawn in all the space available, but so we set a window, right, because we did the scatter plot. So I'm just going to hit graph. And what we see is very close to what we have here. And let me just draw in the median. I always like to draw the median, right, because it should look like it's in the middle, because it is in the middle. And on your graph, it should look like about the middle of the graph, which it does. Right, and then if we go to find this point here, we're saying it should be around 3.88. The second calc intersect. We'll just pop down. So I just go to about the point of intersection, hit enter 3 times. And we get 3.91, and that's just rounding due to me having rounded the values, working this out using rounded values from the calculation. This puts it a little bit later in March, so maybe for us in Calgary, we actually hit spring, or the average temperature just a little bit later in March than we normally do. But you can see how this matches up with what we did here with our scatter plot, and that a sinusoidal curve is a pretty good fit. There are a couple of points that are a little bit out, but nothing way out. And so can we use this to answer any questions? And here's a question. It says, experts recommend changing to summer tires when the temperature is 7 degrees or higher, and recommend changing to winter tires when the daily average temperature is below 7 degrees. Use the graph on your calculator to determine when you should be changing your tires. Okay, so I should be listing Y1. So Y2 is going to be 7. Y1 is going to be my equation, so I'm going to have to pull the calculator up. And all I need to do is pop up to the, we'll go to the Y equals. So I was 12.72 sine bracket, I'll scroll on here, 0.51x, 0.51x minus, so you notice it's plus negative, we'll just go minus 1.98, minus 1.98 plus, that's what I remember, right, it was 3.65. Y2 is 7, our x's, so we said 0 to 13 by 1s, our y's, negative 10 to 20 by 5s. Okay, and then we should sketch out what our graph looks like. Oh, and I want Y2 to be 7. Let's just clear that. 7. Graph. I'm working on the edge of the tablet here. Negative 10, so that's 10, this would be like 20. Then we've got a curve that looks like that. And that's Y1, and then we've got this is Y2. And what we want to know is, okay, when is this, and when is this? So we're going to do a second calc intersect. Second calc intersect. So when we're showing our work for graphical stuff, we're showing everything that's going on here. Second calc intersect. So I want the first time. So this would be putting the summer tires on, right? This is when we reach 7 degrees Celsius. So 1, 2, 3. So we know the Y value is 7. We've got 4.44. So we'll figure out what day that is in a minute. And second Calc, Intersect, and what I'm going to do is just pop down to the red line because it's faster to go across. And this will be in the fall when we should be changing, when the temperature drops below 7 degrees Celsius, and we should be changing to our winter tires. And we got 9.59. 9.59. So to make dates out of those, so the 4 is April, right? Fourth month, April. And then we've got 0.44 times 30, which is 13.2. So April 13th is when it's saying, now we live in Calgary, we know that April 13th is not a good day. Sorry, Yuri, getting a little bit excited. April 13th is not a good day to switch over. I usually wait until the May long weekend. And then 9.59, so what I want, that 9 is September. And then 0.59 times 30, because September has 30 days, is 17.7. So September 17th would be the switch over to, which is actually not a bad day given the times that we get snow in September. So maybe around the middle of September, and I would probably delay this by about a month and take it into May. Although this year, who knows, not a whole lot of driving going on right now. All right, so what did we do? We took a set of data. We took a set of data from the internet, weather records collected over a long time. We ran a regression on that. And then we used that data. Okay, so we put the data into our list, right? And then very carefully checking over to make sure that we have the correct data. We ran a regression. We got an equation, sinusoidal equation. We graphed it, and then we used that. Remember, this is a model, and we use that model to answer questions, right? Based on, in this case, the 7 degrees Celsius time for changing over summer tires and winter tires. And that's it. So that's one example, but it shows everything that we do with the regression from taking a table of data. Now, you'll always be told what kind of regression function to run. So in any test, it's never run the best regression. They'll always tell you which type of regression to run. When you're writing out your equation, make sure that you have a y equals. Make sure that you've rounded appropriately. Make sure that you're writing out an actual equation and not writing something like y is equal to a sine da-da-da, and then saying a is this, b is that. Okay, don't do that. That will get you no credit, right? You have to write out the actual equation. And then, or function, having gotten that function, then we just revert to what we did in the last lesson as far as analyzing the function goes, drawing a graph, matching that up with a graph that we've drawn here to say, hey, they look pretty darn similar. And then we can answer questions about it. Okay, so that's running a regression or modeling sinusoidal functions. And we're done.